All right, so our next set of notes are about inverse relations, which we talked about a little bit when we were doing logarithms and exponential functions, because exponential functions and logarithms are inverse relations. But now we're going to talk about them a little bit more. So an inverse relation is if you have an ordered pair AB, then BA is the ordered pair of its inverse. So it just switches the x and y values around. So which means the domain and the range of the relation switch places for the inverse function. So the x values become the y's, the y values become the x's, the domain becomes the range, and the range becomes the domain. So everything flips places. So if the original relation and its inverse are both functions, they're considered inverse functions. And remember, a function means that for each input, there is only one output value for that input. So to find the inverse function, you switch x and y in the original and then solve for the new y. All right, so let's start with we have this table of values. So we have the x's and the y's, and we're just going to write the table for the inverse of relation S. So the new x and y's for the inverse, so this is our inverse. All we do is we take the x's that are here and make them the y's over here. So 0, 2, 3, and 4. And then the y's over here become the x's over here. So -1, 0, 2, and 3. And now these are the x and y values of our inverse, and these are the x and y values of our first relation. All right, so then we're going to talk about what the graphs of those look like. So on here, mine are already graphed because I didn't want to keep flipping back and forth on the screen. So the green ones are inverse, and the red ones are our initial relation. Okay. And actually, one of these points is not graphed correctly, so just a second. This one should be. Okay, so now we're good. So if you look at these, when you graph them, here are the original, here is the inverse. What happens when you have the inverse and you graph them, it's actually a reflection over a specific line. And that line is the line y equals x. So if you draw the line y equals x through here, you'll notice that all of our points are perfect reflections over that line. So another way to think of an inverse is a reflection over the line y equals x. Okay, so this is the line y equals x. All right, moving on. So, as I just said, the graphs of inverses are reflected over the line y equals x. So to describe a relation or a function by an equation in x and y, you can switch x and y to get the equation for the inverse. So the inverse of a function is denoted by f to the negative first power. We read f to the negative first power as the inverse of f or as f inverse. So we don't actually read it as f to the negative first. You say the inverse of f or f inverse. The notation f of x is used for functions, but the relation f to the negative first or the inverse of f may not be a function, so f of x is not used. So this is only used if we know for a fact it's a function, and this is used if it's just a relation. So we do know it's a function and we have this, the -1 exponent goes in between f and the set of parentheses. All right, so let's find some inverses. So we have the relation y equals x squared minus 1. So we have a quadratic function. So we want to know what the inverse of the relation is described by y equals x squared minus 1. So to find the inverse, you take the x and the y and you switch places. So it becomes x equals y squared minus 1. But we need our relations in y equals form to graph them. So now we're going to solve this for y. So the first step to get y by itself is to add 1 to both sides, so that this becomes x plus 1 equals y squared. Now, to get rid of the squared, we have to take the square root of both sides. So remember, anytime you take the square root, it's plus or minus. So the plus or minus square root of x plus 1 equals y. So now this is the inverse of this function. Okay. So you switch x and y, resolve for y, so that it's just y equals the new function or relation. All right, so now on the next part, we're going to graph y equals x squared minus 1 and its relation. Okay. So one easy way to graph x squared minus 1 is just make a t-chart, and for x squared minus 1, the vertex is going to be at 0 because there's no b value. So you can use -2, -1, 0, and 2, just like we have for the last several functions that we've done. So plug 0 in, we get 0 squared minus 1, so this is -1. And if you plug -1 in here, so -1 squared is 1, so then we get 1 minus 1, so this is 0. And then if we plug -2 in here, you get 4 minus 1, which is 3. And then remember, these reflect over the vertex, so 0 and 3. So we're going to graph that. All right, so it should be interesting trying to draw a parabola on this drawing tablet. So we'll see what's going to happen here. They're better than when I make them in class. We'll just go with it. Now, to graph the inverse, we'll do it in yellow. The x and y of the inverse, remember, flip places. So these x's over here in purple are now the y's in yellow. Oops. That should be -2. And then the y's in purple are now the x's in yellow. Now we're going to graph those points. All right. So the purple is our original relation, and yellow is our function. Our inverse, sorry, not function. So purple is the original relation, yellow is the inverse. Okay. Now we're going to determine if these are actually functions. So if you look over here in the purple table, each input has its own unique output. So -2 goes in, you get 3 out. Yes, there are 2 3s over here, but that's okay, as long as it doesn't go to the same number in the x column. So this one is a function. But if you look over here in the yellow one, you have 2 3s over here, but one goes to -2 and one goes to +2. So it doesn't have a unique output. So this one is not a function. Okay. So the original was a function, the inverse was not. It doesn't always work that way, but that's what is happening with this situation. All right, moving on. So we have the function f of x equals the square root of x minus 2. And we want to find the inverse of f. So we're going to find the inverse of this function. So we're starting with f of x equals the square root of x minus 2. Now remember, f of x and y are the same thing, so if you want to replace f of x with y for this step, you can and probably should. And now remember, to find the inverse, you switch x and y. So now x equals the square root of y minus 2. And now you're solving for x. No, we're not solving for x, we're solving for y. So we need to get y by itself, which means we're changing what's happening to x. So to get rid of this square root, you have to square both sides, because remember, a square root and a square cancel. So it becomes x squared equals y minus 2. And now the only step left to get y by itself is to add 2. So we have x squared plus 2 equals y. And this is the inverse of this function. Now, our next question is asking if the inverse of f is a function, and we're going to explain why. So one way to determine that is to graph this. Okay, so we have y equals x squared plus 2. Okay, so I'm just going to copy this graph real quick. There it goes. Now it'll let me paste. Nope. There it goes. All right, so now we need to make a chart. So we're using the function y equals x squared plus 2. So once again, we don't have a b value, so we can just assume our vertex is at 0, so we can use these 5 numbers. So if you plug 0 in, you get 2. If you plug -1 in, you get 3. And if you plug -2 in, you get 6. And then reflect them. And that's what that looks like on the graph. Well, that one's not good, but just go with it. Okay, now, there are 2 ways technically to determine if something is a function. It's to look at its t-chart. So in this case, we have our input values. Each have their own output value. Wow. I'm struggling to get through this. Output value. Okay. So which means from the table, yes, it is a function. Another way is, remember the vertical line test, where if you draw or imagine vertical lines through this, the vertical lines only cross through the graph once at each vertical line. So this one passes both tests. So this one, so f inverse is a function. And this is your explanation. And that's the end of this set of notes.